Afternoon, folks. This time around is AS or A-level computer science. I want to tackle hardware, software, logic gates, computer architecture, fetch and execute cycle, input, output, memory, and storage, as well as operating systems. So there we are. Let's see what we have in detail. Um, right, there we are. We have computer and its components, sensors and control, logic gates and circuits. Right. Our main objective in this series is to be able to distinguish between primary and secondary storage. And when we talk of primary storage, here we are interested in memory such as RAM and cache or cache. So here we are talking of RAM, cache, you name it. And when we talk of secondary, here we are interested in storage drives such as HDD, hard disk drive, or solid state drive. Let me explain RAM versus ROM. So RAM, that's memory which is used by the processor as it executes instructions. So that's random access memory. And ROM, this is non-volatile memory. In other words, when we lose power, we don't lose the contents of the memory itself. For instance, the BIOS settings. Then we have SDRAM and DRAM, static and dynamic. We have programmable read-only memory, electronic programmable read-only memory, and we have electronic erasable programmable read-only memory. Then also we'll be interested in operation of common hardware devices. Then we explain the use of buffers, which are temporary data storage areas where these are the sections which safeguards the processor from being overwhelmed by instructions or data to be executed. We have the monitoring and control systems. Here we'll be interested in the role of sensors, they monitoring or controlling. When they monitor, they just reading data, but if they are controlling, it means they take action after the data has been read. Then we have logic gates, not and or, NAND, NOR, XOR gates. We're going to be interested in constructing truth tables for this type of gates. We'll see them as we move. Right. So here we are with a bit of examples. Primary versus secondary storage. We said RAM, that's primary storage. This is directly accessible by the CPU. One of the advantages is fast because it stores instructions being executed by the CPU. We also have SSD and HDD. These are secondary storage. They are long-term, but they are slower, though they are non-volatile. In other words, when power is lost, contents of the secondary storage is not lost. What do we store in the secondary storage? We have things like the operating system itself, application software. This is generally software components and data that we want, files, be sound, text, you name it, database. All the backup files will be found in our secondary storage memory. So let's have a look at a comparison between RAM and ROM. We spoke about one earlier that RAM is generally faster as compared to ROM. And another one is volatility. We are saying with RAM, data is not lost. I mean, data is lost. That's with RAM after power has been lost. But with ROM, ROM is non-volatile. When we look at the idea behind reading and writing, with RAM, we have read-write, but in ROM, mostly it's read only. So we're looking at static RAM versus dynamic RAM. SRAM is faster, DRAM slower. And we'll look at SRAM. Part of the reasons why it's faster is use flip-flops. But with DRAM, we have capacitors there to store charge. Then SRAM, because it's faster, generally it comes with an expense. DRAM is cheaper. Static RAM, we use it in cache, whilst DRAM is used in the main memory. Then we have read-only memory where we are saying PROM, that's programmable once you write it, you can't erase data. But with EEPROM, that's erasable with UV light, it's reprogrammable. Once you feel like changing the instructions with EEPROM, you can. Then we have EEPROM, that's erased electronically, electronic erasable programmable read-only memory. It's byte level erase. Then operation of hardware devices, we have laser printers, and we know printers, the output devices, devices. Their purpose is to use laser to charge drum, toner, then heat fusing. We have hard disk. This one is secondary storage, and it uses magnetic platters, and these are the ones which perform read or write via the head, which will be moving. Then optical drive, with these are the ones which use laser technology, and there's a reflection there of piece and lens in order for data to be read. We spoke about buffers earlier. These are used to compensate for speed differences between devices, e.g. printer and the pages being printed. I mean, if the data sent or fed from the CPU is larger than the print rate, then buffers are needed to temporarily store the record or information of tasks to be executed. Now we have sensors. Sensors, these are temperature sensors, moisture sensor, pressure sensor, light dependent resistor, infrared proximity. I mean, sensors, they're there to read data, but some, when they read data, they perform action. So we then subdivide them into either monitoring or controlling. So monitoring, they control data only, e.g. heart rates, but with control, like LED lights or street lights, those where if light reflected reaches a certain level, then they can switch on to show that maybe there is an imbalance between darkness and light. When there was a problem or an example to be done under NAND gate, I think we'll address that in our classwork questions. So here we are interested in defining primary storage, and we give two examples. So primary storage, this is memory used by CPU. In other words, it stores instructions to be executed readily by the CPU. So for this type of memory, primary, we have examples, RAM, and we also have cache. These are type of memories which are primary. Define secondary storage and give two devices. This is memory used to store, let's say, programs such as OS, files, etc. So I've given examples of secondary storage. We have hard disk drive, SSD, even our USB ports. They are all secondary storage devices. Step one difference between RAM and ROM. Major difference there between RAM and ROM is volatility. With RAM, RAM is volatile, and ROM normally it's non-volatile. It's used to store some boot up information of the computer, like the BIOS. You don't need to make changes, so it will be read only. Why is DRAM slower than SRAM? So we said SRAM, it uses flip-flops. So this one uses flip-flops, hence it's fast, whereas DRAM, it uses capacitors. Store charges and information. Explain why EEPROM is, or how it differs from EEPROM. It's the manner in which data is erased as we want to reprogram. So this one, it uses electricity, electronic, and this one, it uses laser to rewrite information. Describe the purpose of buffers. So these buffers, we call them temporary, temporary, temporary data stores. So buffers are used to, manage the pace at which instructions are being executed by the CPU. In other words, we're trying to safeguard the whole system from being overwhelmed. It's more like you receive more, but the pace at which you're executing is slower, so we need buffers for that. Give two examples of sensors and describe their use. or sensors, temperature sensor. So, and it's used to control maybe the temperature of the environment. It reaches a certain point, maybe the certain triggers which will be taken. We can look at the medical equipment like ones which monitor heartbeat. So we can say heartbeat monitors. So these are also sensors which check whether there is a change in the rate at which the heart of an organism is pumping. Explain the difference between a monitoring and a control system. Well, with monitoring, it simply reads data. Monitoring, monitoring reads, basically it's reading information, reads data or information. But with control it does both. Control reads and takes action. That's what a control system does. Then next we are interested in drawing the symbols for NAND and NOR. So NAND is similar to AND gates, but because we want to reverse the sense, so we can put a bar there to say whatever that we feed, we will reverse it, and we have our X here. Alternatively, if we don't put this bar, I mean, we'll put a 0 there that we are reversing the end. Then with NOR we'll put an OR gate like this with two inputs, A, B, but because we want to negate the output, we'll put a small circle there. Then lastly, number 10, we want to construct a truth table for the logic expression A and B. So A and B. So it's going to be A, B, but there's C, because remember there's not C. So we can have it in this manner. Let's see if we can win in terms of space. Let's see. Do we win? Oh, it looks like. So I'll start because there are three combinations. So they will give us 2 to the power 3, which is 8 possible bit combinations. So it's 0, 1, 0, 1, 0, 1, 0, 1. That's 8. Yeah, I have, let me try and check if I'm doing it properly in line. Sorry about that. Let me push it sideways to say here. I have 0, 0, 1, 1, 0, 0. Then 1, 1. Then finally, I have 0, 0, 0, 0, and 1, 1, 1, 1.